By putting a line in the slope-intercept form, it makes it very easy for it to graph. So what is slope-intercept form? Well, up to this point, the only form of a line that we've seen is standard form. And of course, standard form is what we have all of our x's and y's on one side and all the constants on the other side. Well, if we rearrange this, basically if we take this and solve for y, what we end up with is an equation that looks like this. Y equals mx plus b. This is slope-intercept form. Now the nice thing about this, when it's in this form, we can visually see two very important pieces of information. The number in front of the x is the slope. And remember how we find y-intercepts, we let x be equal to 0. If x is 0, that goes away. You can see y is equal to b, which means we can also just visually look at this and see the y-intercept is the point 0b. So by putting it in this form, it's easy to find the slope of a line and also the y-intercept. And we're going to see here in a minute how this is useful for graphing. So let's try one of these. Put into slope-intercept form. All right, so let's take a line. Let's say we have something like 5x minus 3y is equal to 6. Now let's put this into slope-intercept form. Well, here we're supposed to take this is in standard form, and solve for y. So this is a linear equation, just follow your steps. Clear grouping symbols, clear fractions or decimals, move all your variables to one side, all the y's are on the left, move everything else to the other side, so we're going to move everything that doesn't have a y to the other side. So I get negative 3y is equal to negative 5x plus 6. Now the order on this side really doesn't matter, but the form I'm aiming for has the x piece first, so I'm going to write the x piece first. The last step, we got to divide both sides by whatever's in front of my variable, so I divide everything by negative 3. We have y is equal to 5/3 x minus 2. All right, so once it's in this form, we can now just look at this and say the number in front of the x is the slope, so the slope of this line is 5/3. And we can also see the y-intercept is the point 0, negative 2, right? If we plug in x is 0, that goes away and we get y is negative 2. So there we go. We have, just by putting in this form, we can easily look at the line and see the slope of the line and the y-intercept. Now, why would this be helpful? Well, think about it like this. If we happen to know a point on the line, let's say that's a point that we know is on the line, and we know the slope of the line, we can actually put as many points on the line as we want, because the slope is kind of like directions. Remember, it's how much the line rises compared to how much it runs. So if I know a point on the line and I know the slope, which tells me how much I need to go up and how much I need to go over, I can find another point. And I can do this as long as I want. Connect all the dots and we can draw the line. So let's try one or two of these to see if we can graph a line when it's in slope-intercept form. So let's get this out of here. Here's our directions. Put into slope-intercept form and graph. All right, so let's say we have 2x plus 3y is equal to 9. Okay, so let's do this kind of in stages together. Do me a favor, hit pause and see if you can put this into slope-intercept form, just like we did here. State what the slope is and the y-intercept. Then come on back and we'll see if we can graph this. All right, if you're back, let's see how you did. This is a linear equation, so we're following our steps. Clear grouping symbols, we don't have any. Clear fractions or decimals, we don't have any. We already have all of our y's on one side, so we want to move everything else to the other side, so I'm going to move that 2x. Last step, divide both sides by whatever's in front of my variable, so I get y is equal to negative 2/3 x plus 3. So the slope of this line is negative 2/3, and the y-intercept is the point 0, 3. All right, so let's see how we can use this to graph this line. Let's start here. Okay, so we have a coordinate system. First thing you do is plot the point we know is on the line. That's the y-intercept, that's the point x is 0, y is 3. So from that point, we're going to use our slope. Remember, our slope is rise over run, and that's negative 2/3. So again, we're going to treat this like directions. So from this point, we're going to rise negative 2 and run 3. Well, that means go down 2, go over 1, 2, 3. Put another dot. Now we can do this again if we wanted to. We could go down 2 again, over 3 again, and put another dot, which means 1. Connect the dots, and there you go. That quick and that easy to graph a line. Now there is one little thing that may pop up here. Remember when you have a negative fraction, the negative sign can go in 3 different places. Right now we have the negative on the top. Remember, you could also put the negative on the bottom, and technically you can just write it out front completely. Because this is what a negative divided by a positive is the same thing as a positive divided by a negative, and both of those answers would just be a negative, right? That's kind of what writing it out the front means. However, if we were to write it like the second way that I wrote it up there, isn't this a different set of directions? Well, yeah, it is, because instead of going down 2 and to the right 3, this says go up 2 and to the left 3. But watch what happens. If you go up 2 and to the left 3, you end up being on the line also. So here's the key. When you, when you have a negative, it doesn't matter if you put it on the top or the bottom, but you only have one of them in this case. So it's one or the other, but you'll get the exact same line, so it doesn't matter. All right, let's try another one of these. How about, all right, let's do the same thing we did last time. Do me a favor, hit pause. Then take this equation, put it into slope-intercept form, say what the slope and the y-intercept is, and if you want to, you can go ahead and try to graph the line. When you're done, come on back and we'll do it together. All right, guessing you're back. So let's go ahead and put this in the slope-intercept form. Following all of our steps, clear grouping symbols, clear fractions or decimals. Get all your y's on one side, get everything that doesn't have a y on the other, then divide. We end up with y is equal to, well, that ends up reducing to 1/2 x minus 2. So this thing has a slope of 1/2 and a y-intercept 0, negative 2. All right, let's see if we can draw a picture of this. 2, 3, 4, 5. And see what we get. Always when you're graphing using slope-intercept form, the first thing you do is you plot the y-intercept. So our y-intercept is the point 0, negative 2. So that point is on the line. Then we're going to use our slope, which again is rise over run. And we're going to use that as directions on how to get to the next point. So that says go up 1 over 2, put a dot. All right, there you go. There's our line, that quick and that easy. All right, so anytime you're graphing using slope-intercept form, you plot the y-intercept and use your slope as directions on how to get to the next point. Now, a few things here. Notice that this 1/2 is actually reduced. Our slope started out as negative 2 over negative 4. Well, if we would have not reduced it, would it have worked? Well, that says do what? Go down 2 and to the left, 1, 2, 3, 4. Notice it still works out the same. However, you always want to reduce your fractions, but even if you don't reduce that slope, you'll still end up with the same line. So the slope-intercept form is a very, very quick, easy way to graph a line. You really want to pretty much do this as your first try. Remember, we have 3 different ways to graph a line. We can plot points, we can plot specific points, the x and y intercepts, or this is our third method on how to graph. This should be kind of your default method when to graph. Also use this method, or at least putting it into this form, if somebody asks you a simple question like, here's the equation over the line, what is the slope of that line? Well, if anytime you want to find the slope of the line, put it in the slope-intercept form and you can just visually look at it and see what it is. So this is a very helpful form that you're going to use from now and, well, until you've done graphing lines.